Okay, let's take a look of what is not finished in ultrasound. So first of all, we talk about the impedance, which is C, and we use the calculation formula to calculate the value of impedance for ultrasound. And of course, we can use that to calculate the speed of ultrasound as well. And also, we could do the relative intensity level using the equations of these two, which is not provided in the data booklet, but I said it should be provided to you when you need it in paper 3. And also we have talked about the choice of frequency. That will be quite tricky. The use of gel, because simply if you do not apply gel and simply use the air and the body skin boundary, most of the ultrasound wave will be reflected, so you can't get any signal from it. So that's why we have to use gel. So what has not been finished is the difference between A scan and B scan. Okay, so in fact there is a video I will put in the description. I think that video actually explains very well. The basic idea of A scan and B scan, if you try to look at the textbook, is simply like X-ray and CT scan, and B scan is simply a 3D version or 2D version of the A scan. So try to pause the video and take a look of this video, and it will explain to you quite well. And I pretty much like this part of not really animation, but this guy tried to draw how it actually works. B scan is actually formed by many of the A scan, and in that case you can form a proper image. Okay, so pause the video now and take a look of that video. Okay, so let's just try to do some example or exercise. Pause the video now. Okay, so this question, very basic one, asking you how ultrasound is produced. So we actually have mentioned it, so let's just go through some key points. So first of all, it was produced by using AC voltage with a high frequency, and that frequency actually should match with the frequency that you need, which is around 1 to 10 megahertz for ultrasound. And we are using something called piezoelectric generator to generate that. And basically the working principle is that when you apply voltage to it, then it will change its shape or the size of the crystal, and that will create the sound. And that sound wave will be the same, like I said, with the same frequency, so that we can create a high frequency sound. The best part is when the wave reflected back to the piezoelectric, the sound wave will be able to convert back to voltage, and in that case you can analyze it with your computer. Let's try the next question. Pause the video now. Part A is asking you what impedance is. Actually, the word impedance is a very broad idea, which if you try to Google it, you also find people talk about impedance in circuit also. Resistance that we learned in circuit is also one kind of impedance. And in fact, the capacitance C you learned in the chapter of 11 also related to impedance as well. And there is something called inductor, where there's a value called inductance, is also something to do with impedance as well. In the maybe a more advanced physics, or in some old syllabus, like the one that I studied in high school, there is something called RCL circuit, which contain all three components in a circuit, and that is something to do with complex number as well. So it was something that no longer in your syllabus right now. Anyway, back to here, impedance. I think the way that you can explain it is simply by referring back to the equation. So you may say it's a product of the density and the speed of the ultrasound in that particular medium, simply. Okay. For B, then it will simply by applying this equation, substitute, and you should find the answer simply. Let's try the last question. Pause the video now. Okay, so part A is actually very simple, as long as if you could recall this equation, and yeah, I mean you just simply substitute these two are both impedance already, so you just have to substitute in. And in fact, if you see ultrasound question, calculation question in the paper 3, you should feel very happy, because that's probably the only way that you have to calculate. Okay, and so this is the final answer with the order of magnitude of 10 to the power of -3, which means it's very, very small. There's no units because this is a ratio only. And therefore, for part B, what you can say about it is very insignificant amounts for transmission, and that also means almost all of the intensity got reflected. So this is what you can talk about.